Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. In today's lecture, we are discussing the second criterion for a good point estimator, that is consistency. So let's start the lecture. Consistency is the second criterion for a good point estimator. So what is the definition of consistency? If the estimator of a population parameter becomes closer and closer to it as the sample size increases, then such estimator is called consistent estimator. What does it mean? If the estimator becomes closer and closer to the population parameter by increasing the sample size, then such estimator is called consistent estimator. For example, suppose x bar is the estimator and mu is the parameter, and suppose mu is equal to 50. Let we took a sample, first sample of 10 observations, and we computed x1 bar that gave us 45. So there is difference between these two values. Next, we took another sample of, let's say, 25 observations and computed from this sample the sample mean again, and suppose it gave 54. So now this 54 is closer to 50 as compared to 45. Why? Because if you subtract 45 from 50 or 50 from 45, so the difference is 5 in absolute terms. As we are taking distance, so we are taking it in absolute terms. But if we find the distance or the difference between these two values, so in absolute terms we will get 4. So as compared to the distance of these two, this difference or this distance is smaller. Suppose next we took another sample N3 of 40 observations and we computed x3 bar, and suppose it gave 48. Now the distance has further reduced, or this estimator further became closer to the population parameter, which is 50. Suppose we increased the sample size again, and this time we took sample size 50, let's say, and computed x4 bar from this sample of size 50, and we obtained, suppose, 49.5. So again it became closer, and this is just a hypothetical example. So suppose finally we took another sample in 5 of 100 observations and computed a sample mean from these 100 observations, and suppose it gave 50.2. So the distance is further reduced. So this is consistency. As the sample size increases, the estimator becomes closer and closer to the population parameter. But do remember, you will consider a distance between the estimator and the population parameter. You should not be confused that it was 45 and next time at 54. So it may be just if the value of the estimator is smaller than the parameter or greater than the parameter, it doesn't matter. But what matters, it is the distance between the parameter and the estimator. So if the distance becomes smaller, so then the estimator would be said as a consistent estimator. So this was just a hypothetical example, just only to convey you the meaning and the logic behind the consistency. I hope this will make your concept clear. If you have any problems, you can ask. Thank you for watching the video.